Now we are moving into GABA and glutamate, and going from monoamines, we are moving forward into the glutamate. That is a primary excitatory neurotransmitter in our brain, and it drives the synaptic strengthening, connectivity, and plasticity. So when we now talk about the long-term potentiation and neuroplasticity, we talk about glutamate. Now the next one is the GABA. GABA is a primary inhibitory neurotransmitter that regulates the timing, precision, and stability of the neural signaling. So the field of psychiatry is moving from monoamines, from these neurotransmitters, into the brain circuits. And the ones that are leading the way is the glutamate and the GABA. So glutamate and GABA directly determines synaptic strength, timing, and excitation, inhibition, balance. So dysfunction of GABA and glutamate leads on to synaptic atrophy in major depressive disorder. So when we have major depression, there is a dysregulation between glutamate and the GABA, and this leads on to impaired plasticity and synaptic loss in key brain circuits. So this lack of balance leads on to clinical symptoms of depression. Sometimes the depression is associated with anxiety, sometimes with sleep, sometimes with bipolarity, or sometimes we have issues with attention, concentration, or cognition. So the role of new medications is to come up with glutaminergic interventions, to come up with creating that balance between glutamate and the GABA. So we have some new medications, and that can be helpful. So we talk about dextromethorphan and bupropion combination that has been found to enhance brain-derived neurotropic factor and leading on to cultivation of synaptic proteins, and this can lead on to improvement of depressive symptoms. We also have some initial findings in ketamine that can be a rapid onset of antidepressant effect. Ketamine is a non-competitive NMDA receptor antagonist that rapidly modulates glutaminergic circuits and downstream synaptic plasticity. So this is all the new stuff coming up in psychiatry. Thank you.